Hi, this is Mrs. Boykin. Thank you for watching one of my videos again. Today we're going to talk about factoring the sum or the difference of cubes. So our problems can be one of two variations, whether you have two perfect cubes and they're being added together, or you have two perfect cubes and you're subtracting. So each of them follows a pattern, and I'll just go over the pattern. First, we're going to take the cube root of the first term, and let's call that A in this case. And then we're going to take the cube root of our second term, call it B. Whatever sign is in the original problem, you're going to use that for your first binomial. After that, the pattern will follow as the first term squared, subtracting the first and the last term being multiplied together, plus the last term being squared. For the subtraction problem, we do the same procedure, except for the sign of the original problem does stay the same, but this time we're going to square that first term. We're going to take the opposite sign, so that negative is turning into a positive. We're going to multiply the two terms, A, B, together, and then squaring the last term. And so I came up with this little memory trick called SOFAs, which walks you through, after you've taken the cube root of each of your terms, how to come up with the balance, and that's to the phrase SOFAs. And again, I've listed S is square the first term, O is opposite sign, F is first times last, A is always add, and S is square the last term, meaning your B term. So with that in mind, let's take a look at a few problems. I have 3 examples that we're going to do together. Okay, so here's our first problem, and we're looking at 343 and negative 27. Let's go and see, first of all, if there's a greatest common divisor for both of those terms. So let's go to our calculator. I'm going to go to my calculator part, and I'm going to type in GCD parentheses 343 comma, the second number, 27. And we're just seeing if there's a common denominator we should be factoring out up front. And we get 1, meaning other than 1 there is no greatest common factor or greatest common divisor. So let's go back to our problem. And so since there's no greatest common factor, we're going to check to see if these numbers are perfect cubes. So let's go to my calculator again. We're going to find out if, by hitting Control and the caret key, up pops your box. We're looking at the cube root, and the first number is 343. And we see the cube root of 343 is 7. Our other number was 27. So Control caret, the cube root of 27. And we see that's 3. So now we have our 2 numbers that we're going to be working with. So again, we're taking the cube root of 343, but not only just the number, but we also have x to the third. So basically my A term is 7, is the cube root of 343, and the cube root of x to the third is x. Our second term is the cube root of 27, y to the third, and we found the cube root of 27 was 3, and the cube root of y to the third is just plain old y. So let's write those down. Our first term, the cube root, the sign is going to remain the same. We're going to now spell out SOFAs. So we're going to square the first term. So basically we're talking about 7x times 7x. That's 7x being multiplied by itself, squaring it. 7 times 7 is 49. X times x is x squared. Opposite sign. Well, here in my problem, the sign is negative. The opposite would make it positive. F stands for first times last. The first term meaning 7x, the last term meaning 3y, and 7 times 3 is 21, x, y. The A stands for always add. And then the S for the last one is square your last term. The last term's 3y. So 3y times 3y. 3 times 3 is 9. Y times y is y squared. And there we have our very colorful answer, the factorization of the difference of cubes. This whole part is our answer. Leaving one of these two portions off would not make for a correct answer, but the entire answer is your binomial and your trinomial being multiplied together. All right, let's take a look at another problem. This time we see that the problem begins with a negative, and I've advised you whenever your leading term is a negative, we must factor that out up front. So let's go ahead and we're going to divide by a negative, but is there something else I can divide by besides a negative 1? Well, looking at 16 and 2, if you need to do the calculator trick where you're typing in GCD of the two numbers, 16 and 2, it's going to tell you the greatest common divisor or factor is 2. And now how about any variables? Well, I see a y in both cases, so I can divide each by 2y, and this only has a next term. So we're going to factor out our greatest common factor, or greatest common divisor. 16 divided by 2, because a negative divided by negative is a positive, is 8. The y's are canceling out, and we get x to the third. Negative 2 divided by a negative 2 is a positive 1, and y to the fourth divided by y is y to the third. Okay, so now we're going to pull over here and say, all right, well, what is the cube root of 8x to the third? You can put this in your calculator, but the cube root of 8 is 2. The cube root of x to the third is x. Our second term, y to the cube, y cubed I mean, the cube root of y cubed is just plain old y. So let's go ahead and write down negative 2y, and our a term, in other words, is that 2x. Our b term is the y. We're going to keep the sign the same. And this is where the sophist part comes into play. Okay, so we're going to start off by the first s means square the first. That first term is 2x. We're going to square it, multiply it by itself. 2 times 2 is 4. X times x is x squared. Oh, opposite sign. Well, this is a positive. I'm making this a negative. F, first times last. Take the a term, multiply it by the b term. So that's 2x being multiplied by y. And we get 2xy. A stands for always add, and S stands for square the last term. So y times y is y squared. So this problem, with a little bit of a twist, had a greatest common factor in addition to our binomial times our trinomial, and there is our complete answer. Last problem. Oh, we stepped it up. Had to make it a little more difficult. All right, so let's go, first of all, see if there is a greatest common factor. So I'm going to go back to my calculator. Just going to clear my screen, and I'm going to see if there is a greatest common factor or divisor of my numbers, 250 and 128. You may already know what that is, but if you're not sure, it doesn't hurt to double check yourself, because heaven forbid we wouldn't want to get a factor but not get the greatest one. Well, the only greatest common factor between those two numbers was 2. So let's go ahead and divide by 2. 250 divided by 2. Now we're going to take that 128 and divide it by 2. So there's our two numbers that we're going to be using. So coming back to my problem, I'm dividing by 2. Anything else I can divide by? Well, I see both terms have an a in it. I'm restricted by my smallest exponent, so so let's take out an a as well. So my 2a, my greatest common factor, is being pulled out front, and we're going to divide, and we get 125. A to the 7th divided by a makes it a to the 6th, and a negative 128 divided by 2 is 64, b to the 6th. Okay, so now we need to find the cube root. Well, the cube root of 125 is 5. What about that cube root of a to the 6th? Let's see if we wrote out, what does a to the 6th mean? That means a times a times a times a times a times a. We got 6 of them. Now, cube root, if we can make a pair of 3, we can pull one out. So here's a group of 3. So I can pull one out. Here's a group of 3. I can pull one out. So we're talking about a squared. So we have 5a squared is now considered my a term, if you will, minus, and now we're going to take the cube root of 64b to the 6th. So once again, the cube root of 64 is 4, and just like when we multiplied out 6 a's, if we multiply out 6 b's, we're going to be able to make 2 groups of 3, because 3 is my index, and it's going to be b squared. So let's go ahead and drop that in. Minus 4b squared. Don't forget, my greatest common factor, 2a. Please don't forget them, because leaving them out will make a correct answer an incorrect answer. Alright, so let's do sofas. We're going to square the first. So now we're talking about 5a squared times 5a squared. Well, 5 times 5 is 25. A squared times a squared, if you remember your exponent rules, we have the same base. When we're multiplying, we can add the exponents. If you need a visual approach, a squared is a times a, and we're multiplying it by a times a. So that's a total of 4 a's. So we're talking about a to the 4th. So a squared times a squared, same base, add your exponents. Comes up with 4. Opposite sign, that negative is going to turn positive. First times last, we're talking about 5a squared and multiplying it by 4b squared. Well, 5 times 4 is 20. A squared, b squared. A stands for always add, and my last S is square the last. So 4b squared times 4b squared. 4 times 4 is 16. B squared times b squared, again, same base, add your exponents, b to the 4th. And there we have our challenging problem, which really hopefully isn't so challenging after all, and our finished answer. If you have any questions, please feel free to ask your math teacher, or for extra help, come to Cavalier Morning. Hope this helps. See you soon.